There we go. All right.
So I'm curious, just since this is only the third or so AMTA module, how do you all feel about the timing? Like what time of day? Like, does this work for you, or is it an inconvenient time? Would there be a better time just for future planning?
I mean, it works. I like it.
Yeah, this was fine for me.
I know it's hard since you have to do multiple time zones, so this
Right.
works for me.
Works for me.
Good to
I
know.
think the one that we had last week was later, was 2 hours later.
I would prefer it earlier, like
Okay.
this. Yeah.
And you are in Illinois?
Right.
Yes, okay.
All right. I think.
Well, Teresa, it's
Yes.
past 2:00 here.
Yep.
What do you think of maybe we just start some introductions and hope that the rest of the folks join us while we're doing that?
Yep, I think that sounds good. I just hit share, but I can take that back down so we can do introductions. All right. Okay.
Okay. Well,
Okay.
I'm Jeremy Secaur. Teresa and I are co-hosting this. I am a physics teacher on the far west side of Cleveland, Ohio. I've been at it for about 20 years, modeling for 4 or 5 of those years. And yeah, and I'm just eager to hear what it is that you would like to get out of this module. If you could tell us who you are, where you teach, and what you want to get out of today. But first, we'll hear from Teresa.
Excellent. Hi, everybody. I'm Teresa Marx. I'm a chemistry teacher in the greater Boston area and also involved in STEM Teachers Mass Bay, which is an affiliate of AMTA. So in my not so spare time when I'm not doing modules or taking a class with Colleen, working on putting programs together in the area, including summer workshops. And I'm excited to be here. So thank you all for being here on a Sunday afternoon. And
Yes.
we'll pass the baton.
Okay, I'll go next.
Okay.
My name is Wendy. I'm the AMTA workshop coordinator, and I probably have spoken with most of you, probably emailed with most of you. And I'm STEM teacher in Phoenix. Ariel?
Okay. I'll go next. Hi, I'm Ariel Serkin. I also teach chemistry in the greater Boston area, but not at the same school as Teresa. I just taught the chemistry section of the Intro to Modeling course, which was really fun. And I'm also taking the advanced modeling instruction with Colleen. And yes, I'm, an AMTA groupie and involved in also running professional development programs in this region.
Hi, I'm Jackie. I'm a chemistry teacher in the suburbs of Chicago. I teach in Mundelein, and I'm new to modeling, and I'm excited to learn more.
Hi, I'm Amanda Nicholas. I am in Chicago. I teach physics and chemistry and environmental science, and I've been modeling for 4 years.
Hi, I'm Vicki. I teach at the same school as Jackie, north of Chicago in Mundelein. I teach chemistry. This is my first year modeling and just trying to learn as much as I can.
Hi, my name is Holly. I teach 7th grade in Crystal Lake, and this is my 3rd year modeling, and I'm just trying to learn more information about the program.
Hi, I'm Katie. I teach a CTE class in Southwest Michigan, and I was originally trained in modeling chemistry a few years ago, and I'm looking to bring more modeling into CTE.
Cool. I guess I'll go next. I'm Doug Maley. I'm in Jacksonville, Florida. I'm a first-year teacher and jumped into modeling feet first and just trying to figure it all out and bring this new kind of curriculum to our diocese.
I'll jump in next. I'm Joe Miliano. This is my 2nd year teaching. I teach physics, and I didn't do a whole lot of modeling last year. I did some more toward the end of the year, and I'm trying a lot more stuff this year. I still haven't had the fortune of going to any of the workshops yet, but I am working hard with what resources I have to try and learn as much as I can about how to create a modeling type classroom.
I'll go next. I'm Eileen Gratkins, and I've been a modeler for a while. Can you guys hear me?
Yes.
Yes.
Okay, sorry. I was originally trained in modeling in the 1990s with Larry Dukerich. But I've taken 3 or 4 modeling classes since then, but I've always felt like I want to improve my Socratic questioning techniques. We do a lot of whiteboarding, but I always feel like I could do a better job trying to get them to really think more deeply about the concepts. So that's why I'm here. I teach physics.
Awesome. Physics. Great. Okay.
I think we haven't heard from Trina yet.
Yep. Trina, would you like to introduce yourself?
How did you just talk?
Just talk. Yep.
Okay. Hi, I'm Trina Short. I teach chemistry and physics in a small school in Ohio. It's my 3rd year doing physics modeling, and I too would like a little more help to have questions to draw students' understanding to hopefully the right conclusions.
Great, thank you. So when I think about questioning and the purpose of questioning, to me, the most important thing is that if we really want to know what students are thinking, it's not good enough just to ask them, first of all, because, well, they won't tell you honestly, first of all. If they have a choice between telling you what they think you want to know and what they actually think, they're going to tell you what they think you want to know. And so we have to find ways to draw out what they're thinking without leading them towards what we want them to be thinking. And for me, the thing about modeling that really changed the way I teach, I was using a lot of PER, physics education research informed practices before I was modeling, but I just wasn't getting the conversation that I wanted out of kids. And then when I started modeling, then that really gave me that final piece that I was looking for. And so the idea to me is to structure the course that it's just a part of what we do every day, that the students are talking about what they're thinking. And the new NGSS standards, have so much to do with how students form their ideas, that I think all of these things are really, really important. But have any of you ever heard of the story of Clever Hans, the horse?
Nope.
No? Well, Teresa and I have a short video on that. I'm sorry, Teresa, go ahead.
I was going to just ask if you wanted me to go ahead and load that up, if you were ready for the Clever Hans, or if you want to wait a few minutes.
I think we can do that. Clever Hans
Okay.
was a horse about 100-ish years ago, who apparently could do basic arithmetic, and basic arithmetic could do some simple spelling, I think. And anyway, instead of just me talking at you for a couple of minutes, Teresa's got a video that she's going to show you. It'll last about 5 minutes or so.
Yeah. So I will share my screen in just a moment. I think most of you already have your own sound muted. You may, if you don't already have yourself muted, want to mute it just so we don't get a lot of audio feedback while that's happening. And then after we show that video, or Jeremy, do you want me to put up the link before the video or after? I can put it for the shared folder. I can do that after, I suppose.
Yeah, after's good.
Okay, we'll do that after. Okay, and then up on, so we'll take a look at the video and talk a little bit about that and get through some of the technical details in just a moment. So let me go ahead and share. All right. No, okay. 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 I'm seeing, I'm sorry, I'm going to pause because I see some people shaking their heads. Does that mean then that we're not hearing it? Okay, let me try turning it up. Sorry about that. All right. Better? Okay.
To prove his theory, he schools one of his stallions in reading, memory, and mathematics. 2 years of tuition in his classroom stable paid off, and the horse emerged as an apparent equine genius, confidently tapping out the solutions to problems with his hoof.
By the way, with a little so the here, hi, info, perfect. Here, so how to do it.
Van Osten christened his horse Kluger Hans, Clever Hans. The horse even took square roots in his stride. The stallion invariably got his right and was then rewarded. Clever Hans' reputation was worldwide. Many thought the Wonder Horse a hoax, but Van Osten remained firm in his claim that he had a thinking horse on his hands and eagerly sought scientific respect. The challenge was taken up by Oscar Funst, one of the professor's assistants. He devised tests designed to discover the limits of Clever Hans' intelligence. When shown a number, Clever Hans correctly taps 7 times. But could he recognize the figure if Van Osten himself didn't know it? He taps 3.
Nummer 1. Hans hat 3 geklopft.
The test reveals that Clever Hans has no difficulty reading the numbers if Van Osten himself sees them first. Nummer 3, Anzeige Knopf. Ohne Kenntnis. Van Osten has no idea what the figure is on this card. Neither has Clever Hans. Nummer 2, Anzeige Knopf. The results seemed conclusive. Vielen Dank, Herr Van Osten. The horse got 98% of the answers correct if Van Osten had knowledge of them. Only 8.5% if not. Somehow, Van Osten was unwittingly supplying the answers to his horse. But how? Were the clues in his voice? Another kind of test was needed. Van Osten was asked to stand out of sight, behind the blinders, but where Clever Hans could hear him. Van Osten asked them to count to 7. He answers 3. There were no clues in Van Osten's voice. But would the horse count correctly with Van Osten in sight? Told to tap to 4. This time, he gets it right. It was now obvious that Clever Hans was picking up visual clues from his questioner. But what were they? Oscar Funkst now turned his attention from the horse to Van Osten himself. After watching for a long time, he reported his conclusions to Professor Stumpf. He was now convinced that Van Osten was making small but unintentional movements of his head and eyebrows. A slight forward movement was enough to start the horse tapping, and a raised eyebrow sufficient to stop it. Perhaps these were the signs that Clever Hans was reacting to.
Okay. All right.
So the point here, Teresa, did you want to talk about the point of our video?
Yep. Well, so Jeremy and I make Clever Hans references all the time when we're talking about things going on in our classroom and things that we're stuck on. And what sticks out to me is that I spent so many years as a teacher, asking a question followed by, say, raised eyebrows or wide eyes, or nodding my head expectantly as students were talking. And it took me a while to realize that oftentimes when I thought that they understood something, they were actually just responding to my nonverbal cues as a questioner. And it's been a big challenge for me ongoing to find a way to sort of shut myself down and stop leading students on. As Jeremy said before, they have a tendency to tell us what they think we want to hear when we ask a question. And so we have to be very careful as teachers and as questioners to make sure that we are not feeding them the answer non-verbally. And so we'll be making little Clever Hans references here and there throughout the module. Jeremy, did you want to add anything to that?
Yeah, and I think it's important to recognize that the owner of Clever Hans was deluding himself. You know, he honestly believed that Hans understood these things and knew these things. And so we can do that to ourselves, where we trick ourselves into thinking that our students understand things that they don't. They're just reacting to cues from us instead of actually, you know, we're not seeing learning, we're seeing reactions to nonverbal cues. And it's critical that we be really mindful of that. And also thinking about how students can, like, if they know the context of a question, I know for physics, I'm thinking especially about Newton's third law. If kids know in advance that this is a question about Newton's third law, they can tell you the answer you want to hear. But if you ask them a question where it's not obvious to them in advance that this is about Newton's third law, they answer it wrong. And I'm going to guess every physics teacher here has had that experience before. And so how is it that they can tell us the things we want to hear sometimes, except then when it's not obvious to them what answer they're supposed to be cued for, they just don't know a thing. And so we want to be really careful of finding out what they're actually thinking. And so what Teresa and I would like to do now is think about, actually, before we move into that, we want to talk about whiteboard meetings. But first we should talk, I think, a little bit about just the way we're going to do some business here. First of all, if you go into the participants list, and please holler if you don't know how to find the participants list. But if you go into the participants list, there should be an option where it says raise hand. If you just click on that, like I just raised my hand, and I can lower my hand. That's one way to just get our attention. If you have an issue that you want to interrupt us for, just put up your hand and then we'll know that somebody's trying to interject something. But also, like, Teresa and I do not want this to be like a one directional us saying things at you while you sit there and listen. So, please do feel free to jump in and talk to us and talk to everybody here. We want this to be a conversation. We want a dialogue, not monologues. And Teresa has up on the screen right now. Can you all see the QR code and the URL?
So with that, when you use that QR code or go to that URL, you'll find some information for this module, including some shared files that we'll use during breakout groups in a little while. I also, as you can see, have up there my my cell phone number. You are more than welcome to use the chat within Zoom. You're also welcome to raise your hand in the participants list. But I did want to encourage anyone who, if your connection is spotty, if you can't figure out how to navigate to something, anything like that, I will try to be on Tech Watch, and I have my phone here with me, so I'll be able to respond if there, so that you don't feel that you're being missed or having a problem that you're not sure how to get through. I think again, many of you have already figured out how to turn off your own audio, turn it back on. Same with the video feed, you should be able to turn that on and off as needed. But if you're having trouble, or if you're getting a message like unstable internet, anything like that, you can feel free to reach out to me, either using the chat, using the participants list, or just text me directly. And we'll try to make sure that we help get you back into the fold if anything goes wrong. Yeah. So I'm going to leave that up for another minute or two. Hopefully, once you all get into that folder, you'll see that you won't need this information anymore, because we have our contact information inside the slideshow.
And I just put the URL in the chat as well.
Awesome.
And so there will be some files for you to access through there, all through Google Drive. So there will be some files for you to look at starting very, very soon. So if you could just have that open in a window somewhere, then that would be great.
And again, I will leave this slide up for just a few more minutes, but even though we have a fairly lengthy file, the slideshow has a number of slides, that's really more for your personal reference, either during the program or if you go back and reference later. We will mostly not be sharing screens, so that we can sort of have the gallery view and be as best as we can having a conversation and able to see everyone's faces. So I'll plan to go ahead and take this down. And again, I will do my best to monitor the participants list and also any texts or chat messages that come in from anyone who is needing a little bit of extra help.
Yeah. So there are different ways that we have dialogue in our classrooms. And I know that most of us here have some experience with modeling one way or another. Um, and so one of the most common things that happens in a modeling classroom is we have a whiteboard meeting after we do an experiment where we're all trying to collectively build an understanding of what does this experiment tell us, and we start to build a model from that. And that involves one set of skills for how do we hold conversations that are meaningful, where we're not just feeding student answers. Another way that we have dialogue in our classrooms is when students, individual groups share, here's what we did, here's our work. And there's some similarities and some differences with the way that we question a single group sharing their work versus the whole room talking all at once. Sometimes we have whole class dialogues that don't revolve around student whiteboards. Sometimes we're just talking with a single group as they're working through something. And all of these involve similar skills, but the way that we run them would not be the same. So something that I noticed from the survey that we sent out about a week or so ago is that a lot of you are very interested in how do we have dialogue, how do we question, say, one single group's whiteboard. A lot of people also wanted to look into board meetings where everybody's sharing, and so that's where we're going to start. We're going to think about board meetings and how do we prepare for a whiteboard meeting, which, by the way, I know that I've had the experience where I've come to a board meeting underprepared, and inevitably those are the disastrous ones. When I'm not ready with what do I want to get out of this. And I had that experience not long ago where like we had just had some snow days and we're coming back to school, and I thought, okay, well, this won't be that big of a deal. We just need to whiteboard our results from the lab we did before the snow days. It's a really simple result. Like we'll be done with this in no time. And be like snow days or whatever, I just came into class unprepared, and my board meetings did not go that well. Um, so it can happen to any of us when we're not prepared correctly. Um, and so how do I prepare for a board meeting? First of all, I have to decide what's really important to me and what's not that important to me, because I'm sure that students are going to do things that I really would rather they didn't, but also is a secondary or even tertiary point where I don't want to dwell on that. I don't want to get stuck in the weeds of sig figs or something like that when the real issue is something altogether different. So having clear goals in mind about what's really important to me is important, like what needs to be accomplished today, and thinking about what kind of mistakes I'll expect to see. And then I'm looking at their whiteboards while they're creating those to see like what are they saying, because if I'm surprised by something that's on those whiteboards, I'm not going to lead a good meeting. Is anybody familiar with the concept of seeding an idea? Yes, no? Thumbs up if you're familiar with what I mean when I say seeding. Okay, I see a couple of thumbs up. I saw a sideways thumb. Teresa, do you want to talk about what seeding is all about?
Sure. So sometimes, particularly, and you'll see when you get into your groups that we've given you examples from labs. And so typically if students do a lab, there is some big idea that you are really hoping that they're going to get out of it. And sometimes you simply realize that they have prepared whiteboards that have totally missed the point, or they have danced around the point, or they have maybe gotten the opposite point from what they want them to get. And so rather than rather than having a meeting, having a discussion, none of the students know what they're talking about, and then the teacher just stands up at the end and says, well, this is what you should have learned. Seeding is an approach where you sort of sneak into one of the groups, whisper in their ear, why don't you talk about this, or have you thought about that? And then essentially you get the idea brought out in the group conversation, but it comes, or at least seems to have come from from one of the student groups. So that's what we mean by seating. And it's, again, just a way of when you need to have that teacher moment of introducing a specific idea, you do so through a student rather than directly.
And I like to use seating also for maybe if there's a group who's right on the cusp of figuring out something that just goes one step beyond, or they have figured out something that goes one step beyond, then as they're creating their whiteboard, then I'm just going to push that idea a little bit just to make sure that they bring that up in the board meeting. Even if that's not something that's going to come up until 3 days from now, then that idea has been planted by a student or a group of students. So just to give some encouragement to like, wow, that's a really interesting point. Hey, can you make sure that you bring that up when we're sharing our boards today? And so then, we can, they bring that up, and then we can so that goes a little bit beyond where we are today, but let's keep that in mind, and we'll just put a pin in that until a little bit later, and then a couple days from now we can come back to it like, hey, do you remember when that group over there said this one thing? To me, I find that really helpful because it feels more like the students own it, and the students feel proud, like this was my idea that's pushing class forwards.
Awesome. And Wendy just put in the chat, if anyone saw that pop up, that Dwayne Desian had used that extensively in his dissertations, and a lot of his work in his dissertations is now shows up in the way we run workshops, including seating. Yeah. Awesome. So are we ready for breakouts, Jeremy?
Well, do we want to talk? I'd like to ask everybody before we go into breakout sessions, if there's anything that you'd like to talk about regarding how to run a whiteboard meeting, to offer some thoughts or to ask some questions. Then what we're going to do is we're going to move into subject-specific whiteboards. We have some sample whiteboards for you in that shared folder. And then we're going to give you some time to talk through what's the big idea that we want to hit on, what kinds of questions could we ask that would lead our students towards those ideas. But first, before we do that, I just want to open up the floor to anybody who wants to say or ask anything.
I'd like to hear more specifically about people's planning processes for whiteboard meetings. I'm finding a lot of what I do is often more reactionary than it is planning.
You said earlier.
And so I'd like to hear more about how people are coming up with, this is the conversation I want to have. How am I going to make that happen?
Thanks, Joe. That is a great question. And to me, the first thing is, why are we doing this experiment? What's the point? I'm doing the experiment as a lead into a new idea that we haven't studied yet. And so what I'm thinking about is, why does this experiment need to exist in my class? My class days are precious. My class time is precious. Why am I spending it doing this? What are kids going to get out of it? What will we know afterwards? What could we know afterwards that we don't already know? And that's what drives my process. I want my students to figure out this idea. So in designing the experiment, I'm thinking about them creating some kind of data set, some kind of graph, etc., that's going to lead them to an idea. And then in the board meeting, then I'm thinking about, how do I get them from this graph they made to recognizing the idea that I want them to come away with. Am I making any sense so far?
I think in terms of bullet points, and it depends, some teachers like to have a set of cards with 5 or 6 questions that they know they'll ask. Others just sort of spitball it. I generally try to think, what's the goal of the meeting, /lab/ whatever we're talking about? What are the misconceptions and mistakes that students are likely to have? and what is on their whiteboards. It's important that the teacher not be surprised by anything that's on a whiteboard. So
Yes.
previewing, looking over their shoulder, even if you don't wind up doing a seating sort of approach, you do want to know what they have on their whiteboards and be prepared to address anything that you see on there. So those are sort of it. That's usually how I think about it. Big idea, misconceptions, and what specifically do we see on the students' boards.
Then do you usually have them whiteboard like the day before so you could plan that stuff? Or like, because a lot of times me doing it this first year, I'll have them whiteboard and then we might go right into the discussion based on how things kind of planned, like just timing wise.
Mm-hmm.
And so I can go around and look at their whiteboards, but I wouldn't necessarily have a big planning session between seeing what's on their boards. Like I don't have that time, even though I have a little bit of time, because I always kind of have an idea of what's on their boards, but I can't really, I don't have the time to prepare. So as someone who's been doing this for a while, do you try and end class with creating the whiteboard so you have time to look through that then?
I think sometimes, like if it's a quick experiment and they can make a whiteboard at the end of class before they leave, then that frees up more time the next day. And I'm always glad to have more free time. But most of the time, I would say my students finish collecting data, making graphs, etc., by the end of class, and then begin on their whiteboards the next day, like what you're saying you do. So that's where having an idea in mind of what are students likely to do, what are their likely mistakes, noticing the patterns they're seeing before they make the whiteboards, talking to them the day before, then I start to get some sense. And then as I'm watching them build their whiteboards the day of, that's why I think it's so important to have a plan for where are we beginning the day, where do I want them at the end of the day, and then I guess I like to torture myself. So it's kind of a fun intellectual challenge to then figure out because each class period turns out differently. I'm looking at these whiteboards thinking, okay, with what I'm seeing right now, how am I going to get them to this end point that I want? And so to have a clear end point in mind, you won't get there if you don't have that clear end point. And if you don't, like I was saying before, if you don't think about what's essential, what would be nice, and what's really unimportant, and you have to make sure that you get to the essential points today. If you get to the essential points and there's more time, then there's some things that would be nice to come out in the board meeting, and then everything else, just let it go. So just knowing where do we need to end up by the end of class today, then as you're looking at the whiteboards, then you're planning in your head, what questions can I ask about these whiteboards?
It does, Vicki. I find it becomes easier the second year.
Yes.
And easier
Oh, yes.
still the third year.
Good.
Because the first time
Yes.
around, I mean, you really literally might have no idea what you're going to see on those boards until 2 minutes before the meeting. And at my school, we have a rotating schedule. So sometimes I have 90 minutes with my students and other days only 50. And so some days we can have a 25-minute board meeting because we just have time to talk about every minute detail, and other times we're racing the clock and we need to get to that point right away, or we have to hold those boards for the next class meeting. That's not always easy either, depending on how many other classes you have coming in and whether you need to reuse those boards. So it varies quite a bit, and there's definitely some aspect of being able to think on your feet. But what is, I think, the hardest is to give yourself permission to not be perfect that first year, or really ever. But
Yes. I'm not perfect this year for sure.
No, but if you take good notes, what I found is making notes after the fact. Oh, I should have asked this, or I didn't realize they were going to think that, and just have those notes so that next year I was a little bit more ready for it. It's a helpful strategy to give yourself
that definitely helps.
Yeah.
Yeah, and you definitely have to forgive yourself for all the board meetings that don't go according to plan, because there'll be plenty.
Yes, there will.
I always feel bad for my first period because second period goes so much better than first period. I'm
Yep.
always like, oh, poor first period. I'm not sure I asked them all these questions tomorrow. I came up with them after their meeting. Okay. All right, good. Thank you.
Krista, I see you have a hand up.
Yeah, I think I'm probably in a little bit of a unique situation. My school runs on the mod schedule, which means that my class groupings are not the same from day to day. So the kids I see first today will be in a totally different grouping. They won't necessarily be with their lab team tomorrow when they come into class. And I'm wondering if you guys have any tips. Do you ever put students from different groups together to make their whiteboards for their whiteboard meeting? Because otherwise I sometimes end up where I'm like, no one from your lab yesterday is in this class. And so I end up with either like everyone doing an individual whiteboard or having to pair students with partners they didn't work with the day before.
I think if you are doing a board meeting with whiteboards about student ideas, I think that can be really interesting, because now you're sort of cross-pollinating ideas where, you know, a student who was talking with some other people thinking one way yesterday, now today they're talking to people who have some similar and some different thoughts. And I think that could be really interesting to switch up when they're whiteboarding that next day. As far as a board meeting where they're using their lab data, that sounds like a tough one to me. Teresa, have you any experience with anything like that?
In terms of having experiences where a student who was perhaps the most diligent note taker being absent the next day, that sort of thing has happened many, many times, and so it's not quite as embedded in my daily life as it is for you, Krista. But I've definitely had that situation where the people who are holding the marker and whiteboard were not the people that wrote down their data or wrote it down correctly, or were doing anything other than staring out the window that day. So there is that element to it. I think that there are probably just some organizational things where if you have a lab where you see that everyone's data seems to be pretty consistent, you could perhaps have them turn in their data, store their notebooks in class or whatever, and then the next day they're just whiteboarding some data, but may not have been theirs. It gets a little bit trickier if you have a lab where you're getting substantially different results from each group, either by design or by experimental error. In which case, it seems like you'd almost want to have maybe a set of sample data that they could work with. I don't know. That's a tricky one.
Yeah, I've tried putting them in groups where they all had similar experiments or similar groups. Okay, what can you, looking at all of your data, what can you draw out that's a similarity between, and sketch a general shape of a graph without actual data points because everyone has different data. And that's worked with some success, but I always feel like we're missing a little bit because we have a generalized data that we're starting to present at the beginning anyway.
Right. That's interesting. I've got to think about that.
Yeah, I have not encountered that before.
That's a challenge.
So any other questions that you want to raise or comments you want to make before we move into breakout rooms?
Yeah, I wanted to ask you about something you said earlier, and I don't know if this will come out throughout the class. If it is, you can just wait. But you mentioned that you would talk about, or there are similarities and differences between whole class and single group presentations, and how that. Do you have like a quick overview of that, or how those are different, or how they're similar?
Well, if we're having a whole class conversation, whether that's a board meeting or just dialogue about an idea, then I'm looking for everybody in the room to have some opportunity to play a role in how's this conversation going to go, where we are looking as a whole room to build a consensus. On the other hand, if I've got one group presenting a whiteboard of their ideas, then I still want the whole class to be able to reach consensus. You know, are we all happy with what's on this whiteboard? But there's one group of students who is more on the spot than others, and so I think it's important to be more careful about protecting those students, because we don't ever want them to feel like they're under attack by anybody, by the teacher or other kids in the class. We want them to feel comfortable and safe in being able to say what they think. And it's just a different dynamic when there's 3 kids who are on the spot versus 20. And so we just need to just be mindful of how we guide those conversations. And I think some of those things are going to come up as we move through today.
Okay.
And if they're not coming up to your satisfaction, please just yell at us.
Okay. All right. Thank you.
Mm-hmm. So Teresa's going to move you now to breakout rooms where you're going to be in smaller groups working together.
Yep.
So if you look in that Google Drive, there is a folder called Whiteboards for Breakout Session 1. And some of you are going to be in physics groups, and some of you are going to be in chemistry groups. And so we just have some documents with sample whiteboards. So there will be a prompt of what are these whiteboards about, and there's the URL.
Yeah. So I have on this slide, yeah, hopefully you all have the URL up already. Just to let you know, in a minute, I'll invite you to a breakout room. And breakout rooms 1 and 2 should use the physics lab. Breakout rooms 3 and 4 should use the chemistry lab. And we want you to just use that time in your groups of 2 or 3 to come up with a set of questions that you think might be appropriate to ask during a whole class meeting. In terms of timing, what we're going to try to do here is immediately after you have about a 10-minute breakout meeting, we'll take a 10-minute break for everyone to get up and stretch, use the bathroom, get a drink of water, whatever you need to do. So I'll be setting the breakout meeting time limit to be 20 minutes, but the expectation is that you'll use the second half of that to take a quick break and come back before we debrief the breakout sessions.
And so I would say the first thing you want to do in your breakout group is talk about what do we want, what's the big picture idea that we want our students to pull out of this, and then focus your questioning on that. What questions could you ask that would maximize the chance, I was going to say ensure, but we can never ensure, that would maximize the chance that that you're going to lead your students towards figuring out the things that you want them to figure out. So Teresa, do you want to put them in those groups?
Yep. So you'll get an invitation in just a moment, and have fun.
Hi.
All right. I don't know. Let's see. Katie, did you get an invitation?
Where would I see that?
Let's see. I wonder if I made
I
a
was a
mistake.
little late on signing
I
up
may
for
have.
class.
No, don't worry about it. I may have made a mistake here, so I'm going to see if I can fix this. I'm going to add you to. Sorry. Breakout rooms. Sorry, Katie, you are watching me. not know how to assign you.
I like the Harry Potter books, by the way.
Thank you.
Every time I video chat with Teresa, I just try to pick out new books in the background.
And I see Beaker.
Yep.
Or, no, no,
Yeah, I've got Beaker and
Bunsen.
yep. Jeremy, I cannot figure this out. I don't know how to get Katie into a room.
I wish I would help you if I knew how.
Yeah. Okay. Well, let's see.
And I don't know how to move into any rooms either.
Yeah, I have to assign you to one, and you
Right.
or at least, let's see.
I've got a message that says the host has opened breakout rooms. Please wait to be assigned.
Okay. Do you want me to send you to one, Jeremy? Do you want to check in
Sure.
on people? All right.
Sure.
I'll send you to 2 and then 3.
Okay.
All right. And joined. All right. Put on hold. This is strange. How you doing, Katie? Sorry.
I'm good. Gotta love technology.
Yeah. I see you on my participants list, but I don't see.
I'm often the problem child, so it's fine.
Let's see. I don't want to close all rooms. Remind me what you teach.
I teach CTE, but I was originally trained in chemistry.
Okay. And what CTE do you teach? Is it like a biotechnology pathway, or do you teach?
It is a biotechnology.
Okay, cool. I just left I just started a new job, but my previous job was a school that had CTE program. They were trying to get biotechnology up and running, but
yeah, I'm trying to find a biology workshop to go to this summer. I feel like that would be really helpful.
There's one in Boston that might not be convenient for you, but we would love to have
a
you up
little far from Michigan. A little far from Michigan.
Yeah, a little bit. I don't know. You are in no man's land here. All right, I am gonna try. Let's see. I'm gonna try texting Wendy and see if she can help. Well, hi.
I can see this is working, but when I go into the breakout, I can't hear anybody.
Fascinating. Okay, that's
see
weird.
them, and then it just froze.
Okay. And you were in
group 4.
You were in group 4. Okay. Yeah, Katie, for some reason I couldn't get assigned, so perhaps we are going to be our own breakout group. I'm going to go ahead and let's see. Yeah, I think we're just going to be our own makeshift breakout group. And does chemistry work for the 2 of you?
Sure.
Okay, so I'll put this up as a shared thing, and if you want to have it open on your own computer, that's fine too. But I'll just if you want to take a minute and look through them, they're whiteboards for my class, so it's I already know what they are. Do you both have this open? Are you able to both open it on your computers?
Yes.
Okay. All right.
I can see it.
Okay.
Oh, I remember this lab. Were the sticky notes just questions that other students had for the whiteboard group who made the board?
Yes, and this was so the background is that for this particular class, it's a very small class, and most of them would rather just sit silently and never use their vocal cords at all. So I have tried a variety of techniques, including having them give silent feedback on Post-its, since they were reticent to ask questions out loud to each other. And the second whiteboard is a little hard to see because I managed to get a picture mid stick, but that's also a difficult one because it's so wildly different from the other two. But I think what the hands are covering is that the first box was labeled as zinc. The two boxes with the squares were labeled as 2Cl, and then the one at the bottom was labeled as ZnCl2.
Okay.
That's a good idea. I've never done that before.
So do you have questions about what the big idea of the lab is, or anything about the whiteboards themselves?
Did you have them present their boards, or were they just doing the gallery walk?
We did. We had a whiteboard meeting, and yes, they did, but they had the little sort of, they had the little help, which was that they had the chance to look at the feedback on Post-its in advance.
Okay.
Hey, Jeremy.
Hey, can you switch me?
Yep.
Thanks.
Yep.
Sorry to interrupt.
No problem. Let's see.
So I guess I would ask for, there's going to be obviously some clarifying questions for that second board, because they're not very clear as to what each diagram is representing. Trying to remember this lab. I know we did it.
So if I'm remembering right, the students should be seeing that even though the zinc is changing form, that we're still actually conserving like the particles and that overall in the reaction.
Right. So the nice thing about this lab is that the numbers, the numerical data usually comes out fairly cleanly and lets them get the correct empirical formula of zinc chloride, ZnCl2. That's the easy part. The hard part is that because we haven't really gotten into reactions, balancing equations, anything like that yet, they have are sort of having to apply the idea of conservation of mass on their own. And so you can see then what the what the challenges are with them understanding that.
I guess one of the questions just would be, where are things going and why? Because it's really hard for them to understand at a molecular level what they look like, and so that's what they're trying to represent with the diagram. I would just want to know where are things going and why.
Right.
For me, whenever I'm doing board meetings, I always just continually ask them why. So when they ask or answer a question, I said, well, that might be true, but why is that true?
Mm-hmm. That's a good question.
I always ask, what's your evidence?
Right.
And getting them, giving them some uncomfortable amount of wait time usually gets them talking too.
Yeah. I actually have the opposite problem. My kids this year won't stop talking. So yeah. I think too, I mean, in comparing both boards, I like to sometimes bring up more than one group and then just ask the class as a whole, what do you like about board one and what do you like about board two? And then we kind of create a list of the good things that we like and that we're seeing from each board.
Mm-hmm.
Even though that's part of what they're learning, and it's also part of learning how to model. I feel like I do that a lot.
Right, and one thing I do like about, hi Holly. Oh.
Hi. We're just done, so we're gonna go take our break now.
Super. Yep, you can feel free to mute yourself if you like, and we'll meet back here around 10 after. All right. I should. Sorry, I'm gonna send a message out to everyone that we will.
Yeah, and if we're really trying to focus on them getting from their data that it is VNCL2, then it's great, I guess, if they self-balance out in their drawing, the reaction, but that doesn't necessarily need to happen at this point.
Right. One of the things that I like about these boards is that there is something correct about every single one of them and something missing from every single one of them. So there's not just, you've probably had this experience, there's just that one group that gets everything right all the time. And if you don't switch groups up enough, then the kids start to pick up on that, and they'll just wait to see what that one group has to say. But in this case, there's something right and something wrong about each group that can be discussed.
One thing that I end up doing sometimes, if they're not coming to the answer and we're running out of time, I'll pull up the 3 boards that I think have a piece or a clue, and then put them all together, and we say, you know, not everybody was right, but you all had a piece to the puzzle. And so then that's how we draw a lot of our consensus when we're running out of time.
Mm-hmm.
So that they can leave with an answer.
Right. I believe for this particular class that we did have the time for everyone to go back and completely recreate their boards based on the feedback and then based on the board meeting. That rarely happens. I mean, when I actually do have time, it's fantastic. But we're often racing the clock. I want to make sure that you have a chance to take a break if you need one. If you want to keep talking about this, we can. And if you want to use this time to take a break, well, I'm going to pull everyone back at 10 after 3.
Okay.
Okay.
All
right.
Thank you.
Awesome. Okay. Okay. I actually remembered to hit record again. So.
Oh, good.
Okay. My reminder posted is behind my computer, which is the wrong place.
That's the wrong place.
Okay. All right. Okay. All right, Jeremy. How do you want to debrief?
So we have almost everybody back now. I think we're missing Wendy, who had some tech issues, and she'll be back. I think we're missing one other person. And Wendy is back now. So let's just go in, let's say, numerical order, breakout rooms 1, 2, 3, 4. And if somebody from your group, if you see the button at the bottom, share screen, then you can share anything that you've written out, or you can show us the whiteboards, because not every group has seen every whiteboard. So somebody from group 1 can just quickly share the scenario and show us those whiteboards, and then tell us what you decided was important to you to pull out of students for this experiment, and what kinds of questions you think could help you achieve that goal.
Okay, so our scenario was we have a first-year physics class, and they've spent some time doing creating graphs, calculating slopes, meanings of slopes, writing equations. So they have a little background, and so this is their their first lab, which is that constant velocity buggy lab, basically. So they have a battery operated buggy for those who may not have done this one. And it goes along a numbered track marked in centimeters, and they collect data as to the position of the car over time. And so they measured position, time, and then made a graph. And then this is, there's 4 graphs or 4 boards that we had pictures of. This was the first one. And then this was the second one. And the third one. And the fourth one. I love this. Mr. Secaur turned our car around so it faced away from the finish line. It's so mean. All right. So anyway, somebody else want to talk about what we came up with in terms of questions group? Bueller? Bueller?
Sure, I'll come in and talk. So it's been my experiences that students are quicker to pick up on the differences between boards, and that is where the interesting discussion lies, but I don't want to skip over the fact that the data was linear for everyone. I do think that's an important observation for everyone to notice, at least, and to have said out loud. So the first starting point, I think, is what are the similarities between everyone's data? What was the same regardless of how we did the experiment or which car we were using or how many batteries we had or whatever. I think pretty much the only similarity here is that the data is linear. You'll hear things like everyone plotted X on the vertical axis and T on the horizontal axis, which is also a great thing for students to mention. But I think it's worthwhile to first start with the similarities. And then from there, another thing that is similar, which this might get brought up by a student on their own, but if not, it's worthwhile to have the question in your back pocket to ask, which is, tell me more about the units on the slope and the y-intercept. This is especially vital at this early in the year lab because they're not used to, having slopes and y-intercepts mean something. Those are usually numbers that they have found in a math class, and they can be okay at computing them, but then interpreting them is a whole other beast. And so we need to focus on what those units are telling us. Then we moved on to the questions about individual boards and what was different amongst everyone's groups. And so, how is the graph on one board different from the previous board's graph? So they'll start talking about things like different y-intercepts, positive, negative slope, different values for the slope. And then, so those are just the observations we can make. And then we want to transition from what observations can we make to what are those observations telling us? How do we interpret the differences that are there? And so we have, and you can see it on our screen there, sort of list of things that we would like the students to bring up. And if they don't bring up those specific bullet points, we might nudge them a certain way, which I don't know, might be sort of doing the horse thing from earlier, I don't know, but it's worthwhile to have an idea of what you want the students to be talking about.
Yeah, and a lot of times when I'm trying to elicit information, I usually just say, tell me more about that.
Mm-hmm.
Yes, tell me more is my absolute favorite thing to say because it buys me time to figure out what I need to say next. And it gives me a chance to get a clear understanding of what the student means. Because there's so many times when at first I hear a student say something that sounds like gibberish, and I just tell me more about that. And then when they tell me more, then I realize they're actually saying something that isn't quite what I was asking, but it's actually really clever. And so I can find out that they're not just saying gibberish, they're saying something worth talking about. And I found out because I said tell me more. And it buys me time to figure out what's my next move.
it also helps when they may give you a quote unquote correct answer, but they have no idea why.
Yes.
It makes them provide the evidence for what their conclusion is.
Which actually, that brings up something else that that Teresa and I wanted to talk about before, is the importance of not signaling to clever Hans when I see something on a whiteboard that I agree with. I don't tell him that, and I'm going to ask the same kinds of questions of boards that I completely agree with versus boards that I don't agree with a single thing on the board. Why did you do it like this? How would your graph change if you did it this other? There was that one whiteboard. Mr. Secaur turned our car away from the finish line. How would your graph be different? How would it be the same if I hadn't done that? Or if I did do that to yours? And just asking the same questions of students, no matter how much I agree or disagree, puts the focus on them making their arguments based on their evidence and their thinking about the situation rather than trying to read me. And that's really important, I think.
Yeah, and I really like what you were just saying about how would your graph change if this were, if something were different. And we did that a lot in the class I took this last summer, and it was really powerful because it made you really think about what that slope was and what it represented, and how a change to that would look, what would show differently.
Yeah. And also, just in case a group has stumbled their way accidentally into something that looks great, but they really don't understand it, then asking those follow-up questions really probes at, do they really understand what I want them to know here or not?
Yeah.
So was there I'm sorry, somebody was speaking. Okay, was there anything else that group number 1 wanted to share here? Okay, and so Eileen, if you could unshare your screen, please.
Right.
And now we're going to hear from group 2, which had the same prompt, but they're middle school teachers. And so we're going to see, I hope, that what they take out of this is going to be something very different from what the physics teachers take out of it, which comes back to our previous point about how we have to make decisions about what's important to pull out of this. We have to make decisions about what do I need to focus on, what would be nice, and what details should I just let go. I was thrilled, by the way, I don't know if anybody noticed, but in group 1, I had one of those whiteboards, instead of saying X versus time, said P versus time. I see kids do that all the time, and I don't want them writing P for position, but is that really important today? No. So I'm just going to let that go. But we're going to see with this next group that they probably took a very different approach to this than the first group did, because they have different outcomes in mind. And the outcomes that you have in mind for what do we need to get out of this is what's going to drive your questioning strategies. So can we hear from group 2, please?
Yeah,
Sure.
I think, oh, go ahead, Doug. I was going to say, Doug's going to share his screen, I believe. Or are you just going to talk?
Actually, I didn't document my question.
No, that's totally fine. I was just going to say that as middle school teachers, our conversation was really driven on just getting kids to read the graphs correctly and really questioning, like, what do we want the kids to get out of these graphs, and choosing the appropriate graphs, setting up the graphs, really drove our conversation. So I'll let Doug jump in.
Yep. And so starting with asking groups to explain or identify variability in their data and the causes, potential causes behind some of that variability, and whether or not some of those leading causes could be controlled or not. Another question was, many of you used different types of units, whether for distance does it really matter if at the end of the day when we are building this relationship between position and time? Another question was, why did you choose the type of graph you chose to represent the data? Is it the best type or best way to represent the data, and does it lead you to the proper conclusions?
Doug, can you share with us what you were telling me before about how you just did this with your students and they graphed in a way you weren't expecting?
Yeah, literally, I did this experiment on Friday, and tomorrow they are whiteboarding their results. And so they started submitting them over the weekend in anticipation of Monday's class. And all of them so far that I've looked at chose, for some reason, it seems to be the graph of the default type graph, but bar graphs for their data. So I'm really curious walking into this tomorrow why they chose those bar graphs. And again, does it help them understand the relationship? All right. I think one of the things I'll end up using tomorrow as well is asking them, based on their data, based on their graph, can they use that to put their data or their answer in a for every statement, starting with for every 5 seconds, and then go from there. The car travels, whatever, or see if they can make that leap to a formula relationship to a for every statement. And that's what we captured so far.
I find it interesting. I taught middle school for 20 years, and bar graphs are the default every time. Every time.
Okay. This is my first year, so I was just like, what is this deal with bar graphs? I mean, everything's bar graphs. Okay.
Yeah, I don't know why. Everything goes into a bar graph, just saying.
Good to know. That's funny.
I'm curious. Oh, any questions for Holly and Doug? Okay, I'm curious.
Holly, would you like to add anything?
Oh, looks like we're missing Holly right now.
Sorry, I'm here. I hit the wrong button. It was choppy. What did you say?
Oh, I just wondered if you would like to add anything to our conversation.
Oh, no. The bar graph was the default. I think my biggest struggle in middle school is just getting the students to see the difference between like line graphs, bar graphs, change over time. And I think that if they get that just out of a discussion, regardless of what the lab is, working on velocity slope, I think that you come away winning.
So we can see how the two different groups, group 1 and group 2, because they've got different students, they've got very different objectives in mind, and what questions we decide we want to ask are completely different, because where do we want to be by the end of class today is completely different. Also, I'm just curious, since Doug mentioned for every statements, can I just see like a thumbs up or a thumbs down of how many of you are familiar with the idea of for every statements? Okay, there are a few people who are saying no, so it's probably worth a minute or two just to bring that up, because I know students in 11th grade who can calculate a slope and tell me what the slope is, and they do not have the slightest idea of what does that slope mean. And the idea of a for every statement is built around addressing that kind of idea, where we think about our slope. They can all tell me slope is rise over run. Okay, well, what does that mean? And so in talking about the meaning of the slope of a graph, like we had velocity as the slope of our position versus time graph, but instead of just saying the slope is velocity, then we could say, with the horizontal run, for every 1 second of time that this car travels, the graph goes up, the car goes forwards by 25 centimeters. So for every second of time that passes, the car goes forwards by 25 centimeters. Then you're essentially putting that slope into a sentence form. and you are describing the meaning of that slope in doing so. And I find that that's really helpful. And Ariel, you use those a lot, don't you?
I
Oh,
forgot to
she's
unmute.
muted. Okay.
Yes, yes, I use them all the time.
Did you want to add anything about that?
No, I think you're doing perfect, Jeremy.
Oh, well, thank you.
But we can add some, the Teresa, is it Lauren or Erica who has a ChemEd article on for every statements? I'll find it and I can throw it in the chat if you like.
I know I have Gary Aboud's
Oh yeah,
article,
Gary.
and I can share that as well. But yeah, if there's a ChemEdX article, that would be great. I can put that in resources.
Okay.
Yeah, I don't even teach chemistry, but I find ChemEdX to be a great resource. So
And
yeah,
that's Jeremy's reminder. I need to write my next article.
yes, you do. And Teresa, you can put that link in the chat box. Cool. Can we hear from group number 3, please, then? And if you could, since this is a new set of whiteboards with a new experiment, if you could share that with us first.
It's this. All right, so in the experiment that we were looking at, they put solid zinc with hydrochloric acid, and they took the mass of the zinc before, they knew how much hydrochloric acid they put in there, they let it sit overnight. They then, we boiled off the excess so that then they end up with zinc chloride. They already know how to convert from grams to moles and do those calculations, doing the ratios. So basically where we're at when we're going into these whiteboards is, as a class, we've gone through this lab, we've discussed the lab, we have come to the conclusion that it's a 1-to-2 ratio zinc to chlorine. So we end up with zinc chloride, and we have this formula right there, zinc Cl2. So now they're asked to go back into their lab groups and show the reaction. So that's where we're at right now, is they have gone into their groups and have created these reactions. So now, as Jackie, do you want to do the next part, or?
Sure. So so now the goal of, they make their whiteboards, and the goal of the discussion is to make sure that they all have correct idea about how to write a reaction for the synthesis of zinc chloride, and being able to balance that without saying it, and also knowing what happened to the hydrogen, that it was conserved, but where did it go? So we started with the three we took a look at 3 whiteboards, and we decided to start questioning with the third one. Sorry, the second one. Second one, yeah.
This one.
Yes. So for this one, and we decided to start with this board because it had what seemed to be the most misconceptions in it. So we wanted to address those first. First of all, like, one of the questions that we would ask is, how would you represent each of the elements that are there? Because there should be zinc, chlorine, and hydrogen, and we only, there's a, first of all, zinc seems to be diatomic from what we can see, and hydrogen and chlorine are both squares in those 2 separate boxes. And then so just first, how are you representing your elements? And then why are hydrogen and chlorine in separate boxes? So why would they do that? Just trying to get that understanding. And like, where did your hydrogen go at the end? So why is hydrogen not represented in the after part? Okay. All right, so you want me to talk about the next board?
You can or I can, it doesn't matter.
Okay, go ahead, why don't you?
All right, so then the next one after this one, of course, there will be extra questions based on what answers they give us there. But then we decided we would go to group 3. And so then group 3 created this board, and they have a very nice key, which helped us with our questioning. And our first questioning was, what evidence or why did you represent the hydrochloric acid the way you did? So they have underneath that it's HCl, yet if you look at their key, they clearly represented it as H2Cl2. So that would be one of our first questions that would lead to much more questioning on this board, but that would be where we would start the questioning with this board. And then after that board, we decided we would go to group 1.
Mm-hmm. Do you want me to talk about that one?
That's fine.
Wendy, I don't know if is Wendy back?
Yeah, I am, but go ahead.
You want me to? Okay. Okay, so for this one, we, again, this very clear key so we could see what their atoms were, how they were being represented. And for this, we would probably want to do a count of atoms before and after, and then ask them where did your extra atoms come from? Like to give us an account for all of their atoms, showing conservation of mass. And then finally, what is your evidence that hydrogen was produced in this reaction, and how does your data corroborate that or help you to know that it was there, since we can't see hydrogen?
So we tried to be very deliberate with the way we asked the questions or the groups we chose, because this last group more gets at our goal, where the other ones were kind of looking at misconceptions, so that by the end the goal is to write a reaction, and then we can also not only get a reaction from this that looks more accurate, we can get it balancing. So that's why we were deliberate about the way we chose our boards.
Yeah. And I think choosing the sequencing of what you ask and how you ask it is important. And like somebody brought up earlier, a lot of times you're just seeing these boards minutes before you have these conversations. So that's one of those skills that just takes a lot of time to develop on figuring out the sequencing of questions, figuring out who do I want to ask about first. And I think it's important too that like we can see that there's something that each group has to contribute here. Like the middle board, which I think is nobody's favorite who has really looked at these, but like they do have something that's true on here, in that they have, of the particles they represented, they have an accurate count. Board number 1 doesn't have an accurate count. Board number 3 does have an accurate count of particles. Board number 3 does have that one piece with, it looks like they have H2Cl2, but they're so group 3 has that problem with the H2Cl2. Yeah. Group 1 has a problem where they have the wrong count of particles. Mm-hmm. Group 2 isn't what we hope to see on our students' whiteboards, I think, but they do have some correct work there. And I think that it's helpful to acknowledge that, even like, especially when you can see in students' body language that they don't feel proud of their own board while they look at other people's boards and hear what other people are saying, to acknowledge, like, and I see group 2 over here, like when it comes out that we've got to keep track of the number of particles, to just acknowledge that they have that, so that every group can see that you see something positive in the work that they've done. But also then, as much as possible, to get students to react. And in asking that question, I would maybe follow up. I would ask group one that question about their number of particles, like, does that match up with what you see on other boards? And then they'll respond. And then I think an important move is to open the floor so it's not just a conversation between you and that one group, to ask the room, how do you all feel about this? What do you agree with that they're saying? Is there something else that you would like to add, so that we have dialogue from group to group, not just between student and teacher.
So can I ask a question? When you typically ask students, like, how do you feel about what this group did, do you tend to ask that before you ask your questions, or after, or mid? I don't know how, I haven't gotten a good feel for how to do that best so that they can feel confident asking questions of other groups.
And to me, this changes over the course of the school year, because my students, when they enter my class the first day of school, are not good at talking to each other academically. And that's a skill that I have to cultivate in them. And by April, I think I'm going to be able to, it's going to be a magical day. The day is not going to be this week, but sometime by April, I'll be able to, like, we're in a board meeting and the phone will ring, or the guidance counselor will come to ask me a question, or, some kind of interruption. And I'll just tell them, like, just keep going. I'll be right back. And I come back and they're resolving their own issues. They're talking it out together. By April, I can get my students there, but in September, there's no way. So I have to coach them about how to talk to each other. And so my behaviors are going to be different in September versus April. But what I ultimately want is students talking to each other about their work more so than me talking to students about their work. So a lot of times I'll just start, especially early in the year, I'll just ask a group, like, could somebody from this group, find a whiteboard in the room, and if there's something that's unclear to you, could you just please ask them a question? So I'll pick a group and say, ask some other group in the room a question about their board to clarify their meaning. And then there might be follow-up questions to that, like, wait, so do you mean, and that's where we want our students, is asking each other, what did you mean by this? Why did you do it like that? And hopefully we can get them talking to each other. But when they don't, then I've got to ask the question because someone needs to. Does that help, Krista?
Yeah, I think it does. And I think when they see, there's some piece to, like, them seeing how you question groups and then mimicking that behavior. And some part of it that seems to be, the teacher always asks the questions and we can just kind of hang back and not do it because she's going to step in when we don't do anything.
Right.
And I think that balance is tough.
Yeah.
Eileen, I know you had your hand raised. You're muted, so don't forget to unmute yourself.
Yeah, I had a question just about when the kids are putting their boards together. I get more of it at the beginning of the year, not so much at the end of the year. But how do you address when the kids say, am I right? Is this right? As they're constructing your boards.
Yeah, literally.
Yeah.
I don't know.
Well, what do you think?
Well,
I guess we'll find out.
Okay, that's what I do. I just wondered if anybody had a more creative idea.
That is, I have one of my accelerated classes this year was the students were particularly distressed because they really thought I didn't know. And they would say, do you really not know? And I did sort of walk it back a little bit and say, I do know, I'm just not going to tell you. But that's part of, if that is part of the official Socratic approach, is to sort of the instructor feigns ignorance and draws it out from the students. So if you do encounter, I don't know, maybe that's a rare instance, but if you do encounter students who can't believe that you don't know, well, then you say, this is Socrates has been doing this. This has worked for thousands of years.
Yeah, I actually had an experience about 2 weeks ago with a student in my AP class, which is a second-year class. I taught this kid all of last year, and we're more than halfway through his second year of being in my class. and he asked me a question, and I made the judgment that this was a situation where he needed a direct answer. And so I gave him a direct answer, and he just started laughing because, and he's like, this is the first time you've ever given me a straight answer on anything. I'm like, yeah, well, because I don't. Is this right? Well, we'll find out soon.
Thank you.
So we're all set then with group 3?
I think so. Ariel, I don't know if you were talking to us. I saw your mouth moving, but I wasn't sure. Yeah, but we didn't hear
Better?
you. Yes.
Oh, weird. I also wanted to throw in some things to answer what Krista was saying before. Krista, I have hanging in my room discourse stems. So they're hanging in the rooms, especially at the beginning of the year when my students are not as good at questioning each other. I will say each group you will be you will be responsible for asking another group a question, and we have these discussion stems up on the board to use as well. So that's an idea, and we also have other type of Socratic just questioning techniques that they can use to use each other. No, I bet Teresa's going to look in the discussion tools folder and show that she has them already there.
Yes. Yeah, I did want to just point out that there's a whole bunch of stuff in here that we likely won't spend much time on because 3 hours is not very much time. But those discourse stems that Ariel mentioned and some other things are in there.
Yeah. So Jackie, the ones that Teresa's showing are the ones that I use because, yeah. Teresa and I share a lot. Sometimes a brain.
Thanks. That's helpful.
Yeah, and in that folder there are multiple sources of student prompts for how to get students to start talking, because I think a lot of times students would be happy to join in the conversation, like they want to do what we're asking them to do, they just don't know how to get started. So those question stems that Ariel mentioned, that Teresa and I have in the shared folder, those are great conversation starters, and something that you can do, like Ariel has those posted on her walls. I do too. I also recently laminated a bunch of those. Mm-hmm. And so if I've got a student who's maybe a little reticent about talking, but I know they've got good ideas, then maybe I'll just slip one of those laminated question stems to them and say, hey, sometime today, here's a prompt for you. When you see a time when this fits, then just go ahead and bring this up. Question stems like, what evidence do you have that supports what you're saying here, and things like that. Or I agree with this group because, just to give them some kind of way into the conversation, because there are kids who want that but don't know how to get in. So yeah, definitely check that shared folder.
And if any of you are at a school where you have teachers who model in more than one grade, I'm lucky to have a biology teacher who models at my school. Last year was her first year modeling, and then when I have those kids coming into my class, they know how to have a whiteboard meeting. It is so cool. It was the beginning of the year, the phone rang and I went to answer it, and the kids are having a whiteboard meeting. I was blown away. Totally made my day. And these kids, I teach pretty much inclusion classes. So Jeremy has the AP classes and Teresa has the advanced classes. I have all the inclusion kids. And they are able to do it just as well. And it's really, really fun to hear them talk. And actually, my inclusion kids usually have better answers than my more advanced students do.
That's awesome. So do we want to hear from group 4 then? I'd love to hear how your take on this is similar and how it's different from group 3.
We weren't too different from group 3. We've decided maybe the big ideas were conservation of matter, the chemical formulas for reactants, and the byproduct of the hydrogen gas. And questions, how do your boards compare with each other? What do you think was responsible for the fizzing that occurred, thinking of the group that didn't have hydrogen as a product? And the typical, how did the number of particles you started with compare to the number you ended with?
And I thought it was really important to actually begin by looking at these boards. And I was so curious how, based on, I'm assuming these were Teresa's boards because Jeremy does physics and Teresa does chemistry, that it, thanks Jeremy, that it looked like that Teresa students had sticky notes on them. So it looked like that was a way those students could comment on each other's boards in a more anonymous or safe way, so they didn't have to bring it up in front of the entire class. So I thought that would be a really interesting way to get that discussion started. What are those similarities and differences you're seeing? What do you agree with? What do you disagree with? What doesn't make sense to you? Because those boards were really different, and each had something that we could use to help further develop our model, and then other things that could lead to discussions. So I thought looking at that at first was actually the most important thing that we could do to try and guide our conversations forward.
And for students who are allergic to being cold called, the Post-it notes are a good support because they know before anybody says it out loud what they're going to be questioned on, and when the time comes, they can say, I know, we forgot hydrogen, and it's a good support, particularly for the kids that are a little more shy or reticent to ask questions or answer questions.
So, Teresa, how does that unfold in your class? How do you just pick that apart?
So for that one, and that really was not something that I do in all of my classes, but this particular class is a small class and filled with students who would rather never speak for 180 days at all. And will look at the wall instead of looking at each other's whiteboards, and will look at their feet instead of looking at each other's whiteboards. So I gave them all sticky notes and asked them to do one sticky note for something that I can't remember the phrasing that I used. It was something like one thing you think should be changed, one thing you think is important, or something like that. So sort of like one praise, one criticism, and then the students had the chance to go through and look at their sticky notes before we had the whiteboard meeting.
Right, thank you.
Do you allow them to change their whiteboards before the actual meeting then, if they saw something and were like, oh, whoops, we forgot? Or do you say, will you hold off and explain what you would have changed in the class so we can all see your thinking?
That depends on time. For this particular group, we had enough time that after we had a brief discussion, they were able to remake their boards and represent them. Sometimes we just have to have the quick discussion of, this is what I put down. Now I realize from seeing other boards that it should maybe look a little bit different. Oh, and then Ariel just put in the, thank you for that in the chat, one wow and one duh. Or one huh? Yeah.
Do they actually talk more after that, or are they still quiet?
With that particular group, it's up and down. In that specific lab, they were more talkative, and I do think it relieved some of the anxiety because they knew before the presentations, they knew what they were going to have to answer for, what they were going to have to explain in more detail, and that just made it easier because they weren't surprised by any of the questions. Sometimes it's nice. I like to challenge kids with the questions and make them think on their feet a little bit, but sometimes they're not ready for that. And so support's as simple as sticky notes. Wow and duh. I like that. I'm stealing it. Wow.
That was from Jess, Dragon Maker.
Oh, of course it was. We had sort of an impromptu fifth breakout group, which consisted of people who were having technical difficulties or who were not successfully assigned by me. So I don't know if Katie and Amanda, if you want to throw anything in there, what we talked about.
Sure. We talked too about the 3 boards because we did the chemistry one being so different. And then in my class, I like to take those boards if we're running out of time and bring all 3 of them up and just me kind of lead the questions of what do you like from each boards? What don't you like? How could we make this better? And so having those 3 types of boards where they all had a little bit of right information and being able to bring that back together into the conversation.
I think that pretty much sums up the conversation, and just maybe, we did talk about real quick, like, do we really care about conservation of mass right now, or how do we care about it? How much do we care, and how much time do we want to spend questioning the groups on that aspect of the board?
Mm-hmm. Katie and Amanda both brought up the idea that when all else fails, you can just start asking why. You can take on the role of the 2 or 3-year-old that we've all met before, whose response to everything you say is why. So I think that's a good thing to put in your back pocket when you've exhausted all of the questions you thought you were going to ask and only 2 groups have spoken. Why? Tell me more.
Yeah, I do that a lot in my classrooms where if they're not facilitating where I want them to go, I'll just say, well, why? And then they'll give me an answer and I'll say, that's great and you're getting close, but how have you explained it this way and why have you explained it this way? And so they become more accustomed to know that I'm not going to give them the answer. We also have a rule in my classroom that being wrong is okay. So you can go up there and you're going to be wrong and it's okay. And this is a safe place and everyone's a little wrong and everyone's a little right. So we just have to figure out from those 3 boards or the classroom boards, however many you have, who's the most right and why. So sometimes I'll have a recorder and they'll just write down all of the points that they've gathered from all of those boards. And then we put it in together as our final conclusion.
You know what I do sometimes, Amanda, is that I have sometimes I'll say, what happens if you get it wrong? And they say it's okay. I said, no, we're going to blame so and so, somebody who I know who can handle it. I'm like, if it goes wrong, it's going to be Josh's fault. Don't worry, if you get it wrong, we're just going to blame Josh. Just put one of the kids' names, and then somebody, and if Josh, was like, hey, you blamed me last time, I'm like, okay, then we can switch it around a bit. And then it becomes just a laugh moment. And then their anxiety level comes down a little bit.
I like that.
Mm-hmm.
I like to remind the students that we use whiteboards for a reason because we can erase them real easy.
They're magic.
Yes.
Mistakes are okay.
Mm-hmm.
Why would you ever write something down first? Why would you ever use a pen first? Why wouldn't you want to do something you can erase and change?
So I noticed we've only got an hour left, and there are at least 2 major things that Teresa and I still want to accomplish. One of them is we need to talk about classroom dialogue and setting norms of how we talk to each other to make a safe environment for everybody. And we also want to explore the thing that a lot of you said you were really interested in is like, how do we question an individual group's whiteboard? And we have those set up for breakout session number 2. So we're thinking that we'll take the same approach with whiteboard session number 2, breakout group number 2, where this time we are talking about one group's work at a time, and there's one single group that we're talking to. And if you look in the share folder, then you will see whiteboards for breakout session 2. Some of you will be sorted into a physics group and some of you into a chemistry group. where we're looking at, say, homework or classwork that students have done. And so all the students have done all of these problems, theoretically at least. And now, this group is sharing that work, other group is sharing, this group is doing number 1, that group is doing number 2. So throughout class, we'll see all of these whiteboards. But we're only talking to one group at a time. So would it work for you if we head into the next breakout session and do the same thing we did before of take 10 minutes to plan out? Or Teresa, do you think we need a full 10, or would 5 be enough?
I think we probably need 10 because now the whiteboards are all showing different problems.
Yes. Yeah.
So I think we'll plan on reconvening in the whole group at 4:20. That should give you 10 minutes in your group. So you're most likely going to be with a different group of people this time, but breakout groups 1 and 2 will have the physics problems. 3 and 4 will have the chemistry. And breakout room 4, I'm actually just going to keep here in the main one because that'll, I think, eliminate some of the technical problems we had before. So are we ready to go? Okay.
All right, let's do it. And Teresa, you just dump me into
Okay, you want to go into 1 or 2? Okay.
Put me in 1.
All right, have fun. Okay.
Thanks.
Vicki and Katie, I'm keeping you here.
Okay.
And but we'll do the chemistry problems.
All right.
And while you take a look at those, I just need to set a timer so I don't forget to end the breakout groups at the right time. Okay. Did you both find the file?
Yeah, I'm
Okay.
just reading.
Yeah.
Okay. I'll be quiet and look it over.
Do you let your students call them LOL charts, or do you make them call them energy bar diagrams?
I let them call them whatever they want. Is that?
So their focus is the ice cube.
Yes. And then for question 2, so I think the idea was an ice cube and a soft drink are mixed together, and one question they had to focus on the ice cube, the other on the soft drink.
So I guess for the first board, my question would be, what are we focusing on? And then they could answer the ice cube.
Mm-hmm.
And then what's happening to the ice cube? Because they have the cooling curve and an ice cube.
Right.
So the goal is to try and question them enough to get them to change it to a heating curve.
Right.
So I think I would talk about, all right, so let's just talk about the ice cube. Ask them, so we are looking at the ice cube, what's happening to the ice cube? What needs to happen to get the ice cube to go from a solid to a liquid, because they have that in their particle diagram.
Mm-hmm.
And so that they even have that 2 bars of energy is going into the ice. So hopefully with those questions, then ask them, so what's happening in your energy curve? and then get them that energy is leaving their in that diagram. So hopefully that would kind of lead them there. Right? That's
right. And that's, I mean, I think you'll see on most of these that there's students have most aspects of the problem correct, and there's just something that they've overlooked.
Yeah.
Yeah, and with that board, it might just be as simple as like, oh, what is your energy curve for? And oh, what is your bar chart diagram for? And then hopefully, again, they can realize like, oh, wait, I did the energy curve for like the pop and not the ice cube.
Right.
So you have half energy bars in your
yes, I do. I think it was for free. One half was for freezing as a thermal, if something's frozen versus if something's just cold. I think that was the distinction. 1/2 bar for freezing and 1 bar for cold. And then what about do you want to look at question 2?
Yeah.
Okay.
Yeah.
All right. I was still looking at question 1. But all right, question 2. So this one, we need to have a discussion of how warm was the soda when they circled that portion of the energy graph. Because it was at 100 degrees, obviously.
Exactly. Went from 100 all the way down to 0 with 1 ice cube.
Yeah, and like started the
big ice
cube.
Right.
Teresa, sorry to interject. Can you
yep.
move me to room 2, please?
Yep. Thank you. Bye.
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 Did you not go? Oh, there it is. Okay.
So that was 1 powerful, really cold ice cube.
Yes.
Very big.
Biggest ice cube of all time.
Not sure we could calculate
Right.
how big that ice cube actually truly would need to be. It looks like their particles get further apart.
Yeah.
Yeah.
That's what I just was noticing, asking them about, like, why did you draw the particles the way you drew them?
Right.
Although,
and I do tell the students, I mean, even, by this point, I mean, this is unit 3. So by this point, I expect your particle diagrams to be pretty precise. This isn't this isn't week 2. This is week 16 or something. So you should have very precise particle diagrams at this point.
Oh, and in the next board, there's a heating curve.
Yeah. But it's still a magical ice cube that heats things up.
It is very warm. And then there's no like energy in or out of their O.
Right. There's just an LL. Yep.
Yeah.
Doesn't really
Where
count.
Where does your energy go?
Yeah.
And then it's getting cooler, but their graph shows heating up, heating extremely up, not just a little bit.
Yeah.
Do you focus on how much of the graph they circle relative to the problem? Or are you?
I would, and partly the pushback that I would often get from students would be, well, it doesn't say what the final temperature is. So, well, no, it doesn't, but how many times in your life have you put an ice cube into your drink and you know it gets a little bit cooler? It doesn't, we know that it's not the entire 0 to 100 range that's changing. And this is good too. I mean, I think this is one of the things I like about the set of boards is you see almost every group has gotten almost all of it, but there's some aspect of the representation that has sailed right by them.
Which is nice because this is when I see kids asking each other questions where it's not so, the burden's not so much on me to help them see it. They start asking each other questions. It's just the fine line between, like, especially unit 3, they're usually getting where that environment is set and they know that they're no longer trying to do those accusatory questions, which is what they start off with, is what I found.
Right. We have, do you want to look at the last couple of boards, or do you want to go ahead and take a break right now?
I didn't get a break the first time because Wendy was in my group, and then she was just talking and talking and talking. So
okay, you need a break. Yes, take a break. Absolutely. How about you, Katie? You ready? You want to take a break?
Yeah.
Okay.
I think that's probably a good idea. My attention span is missing.
Yep. Okay. Sounds good. I'll see you at 4:20.
Thanks.
Yep.
Sounds good.
Yep, we've been kicked out. Or kicked back, I guess. Not kicked out.
We've been encouraged to join everybody else.
There you go.
Time flies.
Yes, it does.
My goodness.
And a couple of minutes ago, I put into the group chat, and I see that Katie noticed that they're there. I put in some class norms for discussion in my classroom. Whenever we're having group dialogue, these are the things that this is the standard expectation of behavior. But we can come back to that after we just quickly go through those whiteboards.
Jeremy, can you repost those? Because when you're in the small groups, you can't see things that are posted unless you're posting within the small group.
Gotcha.
Yeah, I was going to say, I'm not seeing them on my end. There they are.
There they are.
Not in quite the format I originally typed them, but there they are. Sure. Anyway, shall we hear from, just quickly, let's we've only got 40 minutes left and we've got lots more to get done. So group 1, would you like to share what you came up with about how to question the whiteboards you saw?
Sure, I can jump in a little bit and talk about that. Let's see if I can find the whiteboards and share my screen. I don't know where that is. Probably here. Share screen, share. Cool. All right.
Got it.
So we're talking about momentum. Specifically, we've got bar graphs for before and after, where the vertical axis is velocity, the horizontal axis is mass. And then we've got the change being a force time graph. And we're talking about a sort of 4-step process. We throw a baseball to increase its momentum. And then at part C, we hit the baseball with a baseball bat to first decrease its momentum in the one direction and then increase its momentum in the other direction. And then it asks a little bit about Newton's third law as well. And so the graphs look something like this. Group 4 here has no momentum before you throw the ball, and then we add some in through an impulse. and we look at some momentum after the ball. The area of this graph is the momentum. And then we look at a similar graph at the bottom for when the person is hitting it. Difference here with the second group is that when the person is hitting it, they show the force and the velocity in the direction that's opposite the ball was moving so that you can turn it around. And group 3 here didn't do anything for part C there. And so we spent some time first just looking at differences between the boards and how we would try to resolve those differences. We talked how this is sort of different than looking for differences in a lab discussion, because in a lab, you know, the differences mean something. Here, the differences mean someone did something wrong. And so you want to approach that differently. And so one thing we noticed that we wanted to address is that in part B, the second group took the third group here took the force set it equal to mass times velocity instead of the impulse set it equal to mass times velocity. And so the way we thought we would address that is by asking specifically about how we translate the graphs that we drew into the math that we wanted to do. And so we put the focus back on the pictures that we drew first and trying to tease out how we translate those pictures into math instead of just focusing on the math piece itself. With this third group here, you can see they represented 0 by writing the number 0. The other two groups drew sort of flat bars that don't have any height to them. So we also thought we would have a discussion about, in our class, what do we think the best way to represent 0 is? Because that is sort of a personal choice for us as a class. And obviously, as a teacher, I kind of have a preference, but I want the class to be able to reason out why that is my preference. Let's see, and then we wanted to talk about the positive and negative discrepancy. And so I think the question that we said that we would use to address that is just asking, what does negative mean in the context of this problem? And hopefully through that discussion, we'd see groups that didn't have a negative force and a negative velocity and make that switch. I know I've seen groups in my own classes, very subtly try to erase it real quick before I draw any attention to it. And I think we'd see something like that in that discussion as well. Anyone else want to add to that?
I guess the only other thing that I noticed is that the difference between the way group 1 and group 2 set up on part B, group 2 either misunderstood setting momentum equal to impulse, or they just skipped to the step where they multiplied the mass by the initial velocity of 0. I might lead into a discussion about, well, does it matter? You got the same answers, you started with different points. Does that make a difference or not?
The other thing that we talked about was just how the first board was very pretty and very easy to read and understand, and I believe the second board just had some wrong units on it. So we talked about how we can clarify with the class on how we want our boards to look. Just another key aspect of understanding what graphs look like and how we can read them and how we can misinterpret them just if they were written incorrectly.
Yeah. Thank you, group 1. Group 2, how did your approach, how was your approach similar, and how was your approach different to the way that you would ask questions about these boards?
I can jump in and start. We struggled with reading some of the graphs and trying to figure out a way to ask them what their graph was saying without actually asking direct questions or getting right to the point. So we were just talking about having the students justify the data that they pulled from the lab and explain why they represented it the way that they did. And then maybe through that kind of question, we get further clarification as to where they were going with their graph. Because we spent a lot of time trying to read the graphs to try and figure out what they were saying. So I think my group can jump in on that.
Well, I think,
So,
Holly, go ahead. Go ahead,
oh,
please.
okay. So just to kind of add to what Holly was saying, yeah, asking them to kind of justify their math processes, also asking them to, to kind of explain what their system was for the worksheet problems, and then so that, because some of the misconceptions were coming from, or at least in the initial set that we looked at, the misconception was coming from what is your system? So if you're looking, it was ice melting in a soda, so they were drawing cooling curves for the ice, but the ice was really heating. So getting at that misconception by kind of looking at, well, what is your system? And now we can dig further and know that it should be heating and not cooling. Some of the misconceptions, like later on, were about units, like using some of they were trying to figure out how much of the liquid would vaporize in a Cheeto lab. And so there were some questions that were given, the amount of, I forget, the last one was given in kilograms, but the calculation gives them grams, and then they took a percentage from that. So making sure that they have units, so getting at, like, what are the units for that answer, and what are the units that what was given in. And then also a question about, what type of energy is being stored during a phase change, because they had liquid, again, being vaporized, and they had thermal energy increasing. So kind of, getting back at that, well, where is that energy being stored, so that they can clear up that misconception about it's heating up, even though not all of the liquid vaporized, so it couldn't go on to heat up.
And I just want to jump in real quick. Something that both Holly and Jackie were talking about was about asking about the process rather than asking about the results. And I think that that's so critical. No matter what I think of what else I'm looking at on that whiteboard, by asking questions about process, then I can see how a whiteboard that looks good, there are still some misunderstandings. I can see how a whiteboard that looks not very good can still have some quality thinking behind it, and so that I can call out those things that like when students feel like their whiteboard, like our results are all wrong. Oh, this is terrible. We don't want them feeling bad about themselves. We want them to feel positive about the work that they're doing, and so calling out, like, I like the way that you did this, when we notice what's right about their processes, even when it doesn't look good on their final product. But asking about their process, whenever else we're stuck on how do I move this conversation forward? How did you do that? Why did you make that choice? Did you have to choose it that way? Could you have chosen it differently? If so, what effect would that have on your results? And asking about the process is always going to help us drive forwards, digging into what are they really thinking. And so we heard from Jackie about the ice cube question. Can we hear from anybody else who was in a group on the ice cube question?
Do you want to have it just for the ice cube, or for when
Or
they
the
move
ice
over
cube,
to the
any of the chem ones.
One of
because
the things that our group was pointing out, and I can try and share the screen, my screen here. Or I'm failing at this. Anyway, was on their heating curve that a lot of times the students were highlighting the whole end from 0 to 100, and pointing out to them, thank you for technical assistance, pointing out to them that's either like the biggest or coldest ice cube you've ever encountered, or we're not really dealing with the entire range from 0 to 100, whether we're heating the soda or we're warming the ice cube. So just trying to make sure that they're really thinking about how much are we dealing with here.
One thing that I like that Teresa kept pointing out when I was in Teresa's group was that each of these boards has a lot of correct concepts on it. And usually there was only like one part that we're trying to get at, or that we're trying to correct. And so one thing I found in my classes when this type of stuff happens is that after a while, not in the very beginning, after a while, the kids start asking each other those questions to try and kind of help correct those minor things, whether it's something looks weird in their particle diagrams or they drew a heating or cooling curve. Like they start getting better at asking each other questions and not phrasing them as accusations anymore, but actually asking questions.
Okay, did anybody else want to share anything about how they could go about asking questions, or ask Teresa or I questions about Teresa or me, questions about approaches to take or anything?
We also talked about the importance of establishing our norms. So whether it's graphing norms or whiteboarding norms, how do we want to approach this? Whether it's when you make your whiteboard so small that you can't read it across the room, that's a time for reestablish what that norm is. And then if our group was looking at the momentum problem, we really enjoyed the thick boy problem. So we were looking at question number 6. There were 3 boards there, and we looked at the different ways each of the groups approached it, and we said, well, do we want there to be a class norm on how we should whiteboard these, whether it's labeling, because we couldn't always figure it out, and then if we're focusing on process, if we're noticing differences, have each of the groups, sorry, you're about to get a cat visitor, what do you guys observe differently about the different approaches, and comment on your approach or comment on somebody else's approach? What questions do you have? Not do you have any questions, but come up with at least one question.
Mm-hmm. Yeah, that makes a huge difference to say, do you have any questions versus ask a question. And to just sit there and soak up that silence while they're not saying anything and you're just waiting for that question. Sorry, Teresa.
No, I was muted and didn't realize it. But yeah, what questions do you have? Ask 2 questions. There are all kinds of ways that you can put it out there that's not, do you have questions? Just make the assumption that they do.
Yeah.
I was curious whether anyone had any insights or thoughts as to the different approach that you might need for something like this, where you're just looking at small presentations a little bit at a time, rather than trying to manage an entire group, whole class discussion.
Could you repeat that?
Sure. Just wondering if anyone has any thoughts or insights, maybe the differences between preparing for a whole class whiteboard meeting where everyone is going to have similar material on their boards versus what we just did, which would be smaller individual presentations where every group is doing something different.
I think it's difficult in a different way because you need to manage the audience also. Like things that you said, like have, sometimes I'll have my kids think ahead of time. They'll look, so you're going to be asked to ask a question, right? Like that sort of thing. So just kind of prepping them so they know that they're going to have to ask a question, so they're not tuned out.
Yeah, and I think that comes back to, like Ariel was talking about, establishing norms for making whiteboards and sharing whiteboards. I think we also need to have norms for how to be the person who's not presenting a whiteboard. Like, what are the right behaviors for while somebody else is presenting their whiteboard to you? Your back is turned to them. No, this is not okay. We need to have well-established. We need to have conversations about what should you be doing. And I had something else in my head and it slipped right out.
Can I ask, what do you do when 2 boards in a row are completely correct? And I have a hard time with questioning them when it's a correct board. When they've explained it properly, no one else has a question, it's just the right answer.
So I would ask about process, anything about the process for how they chose to make their whiteboard that they didn't explain. I would ask, how would this be different if? And, which again is a process question. And so getting into those things is going to help other students realize, it's going to help other students recognize this is good work. When they have good answers to that, and when we can all agree on what they're saying, then students recognize, okay, this is quality work here, and it helps them make some understandings that they might not have had about their own work. Or asking, like, how would this be different if, helps everybody make more sense out of things. And so in asking follow-up questions to a correct group, then we can talk more about how do we do good work without asking it that way.
Thank you.
Mm-hmm.
I think too, if you can, don't let them go back to back. If you notice that there are 2 fairly similar, identical boards, they don't present one right after the other. We bounce around the room if we need to. My students also by this time know that not everyone's going to present every whiteboard at every meeting. Sometimes for time, and sometimes because it's a little repetitive.
Yeah. Oh, one thing that I was also going to add is that I like to make sure that there are going to be some wrong things on whiteboards. Anytime my students are presenting individual whiteboards, I want them to feel like there's a very realistic chance that somebody's going to be sharing something wrong. Like what our brains do, like our brains interact very differently with what people are telling us if we're not sure if we're going to agree with them or not, versus if we know that everything they're going to say is true. So if I will only allow correct whiteboards to ever be shared, then kids sit and politely watch, but their brains aren't engaged at all. Like, well, of course I agree with that because it's right. Even though they have different work than that on their own paper and they never even notice that. But if they think that there is a likelihood that that something's going to be wrong on some of these whiteboards, then they're in a different state of mind. They're looking for, what don't I agree with here? Is there something for me to disagree with? Are they wrong and I'm right? Am I right and they're wrong? Or vice versa, whatever, you know what I meant. But that puts students in a state of wondering, should I agree with this? And so the mental processes they go through are very different. And so sometimes I'll even ask groups, like I saw yesterday when they were figuring this out, that a bunch of groups kept on making the same mistake. And so I'll ask them to share an incorrect whiteboard. Like, okay, great, we've had a lovely conversation here, and now you've changed your mind, but could you do me a favor? Because this conversation that we've just had, I think there are a lot of people in the room who need to have that conversation and they haven't yet. So could you share your whiteboard the way you originally made it before we had this conversation, just to make sure that that conversation is going to come up in the room for everybody to have that conversation? So I'll ask students to be wrong on purpose. And actually, they're sort of secretly honored by that. Like I just heard on Friday, one of the whiteboards that was in the physics boards I shared was an intentionally wrong whiteboard. And a girl even said, as I was walking away, like, oh, I feel so honored. He's never asked me to do that before. And they were just really excited. So that's a way to not have too many perfect whiteboards. Now, it is important, I think, then, that we want to ultimately come to agree on what we do think is correct. We don't want to end with incorrect whiteboards, but to just make sure to push that conversation out there.
We have a couple of questions popping up in the chat, and do we want to talk about them now, Jeremy, or do you want to maybe do that toward the very end? We're almost are at the end anyway, so I want to make sure we get to folks' questions, and I am seeing those of you that are posting in the chat.
Yeah, we're pretty low on time. So let's answer these questions, Teresa, first,
okay.
And then talk about whole class conversation quickly.
Okay. So Trina mentioned in the chat the mistake game. I don't know if you, I'm familiar with it. I don't know if anyone here has experience with that and wants to talk about it. I think that is somewhat along the lines of what Jeremy was just sharing, that you intentionally make a mistake and then go looking for those mistakes.
Yeah, I have my kids do that frequently, and they actually like doing it. It becomes a challenge to see how subtle you can make your mistake. But I do that quite often, especially when working on problem sets. I'll have them work it out correctly first, and then I tell them to go back and change one value somewhere or just one item somewhere, but not to continue the error through the math or whatever. And they actually like that because it makes them look more closely at the solution in order to find the mistake. They know they're looking for a mistake.
And it solves that problem of all these whiteboards are correct, so I'm getting bored and tuning out.
Right.
And I don't have my students who usually do correct whiteboards because, their maths, if it was a calculation issue, because their math skills are very, very low. So we don't have to, we are always playing the mistake game, except they're just their actual mistakes.
Eileen, in the chat, you also brought up the question of whether or not we have students whiteboard every single problem in a question set. And if not, how are they able to check their answers, whether it's a key? I will say for myself that I usually do not have students do every problem on a question set. I will pick out the ones that I think are the most challenging, or the ones that I think are most important for everyone to take a look at. And sometimes I will post keys and let them just check on their own. Other times I will make them do the most awful thing, which is to have to ask me out loud if what they did was right on their paper. And that somehow is much worse than putting it on a whiteboard and letting me tell them whether I think it's right or wrong. But I think there are a lot of different ways you can handle it depending on the students in front of you. You can make it be the unknown question that they have to check with others. You can grant them the information that yes, you agree with their answer. But I think it's rarely practical to do every single question on a whiteboard. I think. I don't know. How about others? Anybody else have?
Yeah, I often do the mistake game and I have them pass the whiteboards around instead of presenting them to the class. I feel like it takes a little bit less time and they still get the same benefit. And I'll often have one group does question 2 and they pass it to a group that did question 3. And so in that process, each group makes a mistake and agrees on what the mistake is for one question and then analyzes it for another question. And so they've seen 2 questions in the time that it normally would have taken to do one.
And that has the benefit also of holding people accountable for more work.
Katie had a question about dealing with students who don't complete the problem sets during class and during the whiteboarding sessions. Does anyone have any strategies that you use? I personally, I'll tell them to complete it for homework, but I don't grade homework. So when they have to self-assess whether or not it's work that they need to complete to understand how to do it. And some students decide that I know how to do the other ones, I'm not going to finish 9, 10, and 11 because I know how to do the first 8. And others will go home and spend 2 hours and then email me and then see me in the morning before school the next day and ask during class and everywhere in between.
Yeah, that's a struggle I run into too. I do pretty heterogeneous groups, and typically at least one kid in every group has done all the problems on the problem set, but that runs into a little bit of problem because then that kid knows how to do the problem, the other kids may not. So what I tell them is, if somebody in your group didn't finish the problem, you're the one that's writing the board. And I try to get them to work together to put together the solution, and that seems to work okay. But I think we all have kids who don't do their work.
Yeah. So we've just got 10 minutes left, and I definitely want to honor everybody's time and be done by 5. Although if anybody does want to stick around after, then Teresa and I can both hang out for a little longer and just answer whatever questions you want to ask. But we did want to talk about whole class discussions. We wanted to talk about whole class discussions, which are different from a board meeting in that with a board meeting, every group has the same amount of stuff to share. And so they automatically have things to talk about. And so we're going to hear from each group. Whereas when we're just having a whole class conversation, then it's a whole lot easier for some voices to get lost or for some people to just duck out of the conversation altogether. Easier for other groups for some students to dominate. And that's where we feel like it's really important to have those established norms of how do we talk to each other when we're having a whole class dialogue. And that's where I posted those a little further up the group chat. The class norms for discussion, share time equitably. In that, there are some people who are pretty sure that whenever I ask the room for their thoughts, they mean that kid. Like I had 2 years ago, I had a class where there were 2 boys who were always sure that their voice was the one everyone needed to hear anytime I wasn't speaking. And so I had to push back pretty hard on that, like, are you listening and talking, or are you just talking? Because both of those are important, and we need to learn how to listen to each other as well as share our ideas. And so it's really necessary to make sure that we talk explicitly about, are you doing your appropriate share of listening in addition to an appropriate level of talking? Because there are students who will try to talk all the time, and there are students who will never talk unless we explicitly prompt them to. And we want to make sure, because the more different voices we have, the more different perspectives we get, the more different ways to approach an idea we have. We need to hear from all different people. And so we can only respect all the different perspectives in the room when we make sure that we're thinking carefully about, am I listening more than I'm talking? And also just to acknowledge, and I always find it's pretty easy to point out, like if you've ever dated anyone, that what you meant and the way it was interpreted don't always necessarily match up. And and we have to recognize that just because you didn't mean something negative doesn't mean that you didn't hurt another person's feelings, and that you have to take ownership of that. And you have to acknowledge that even though that wasn't your intent, that's what happened, is that you hurt another person's feelings. You need to take ownership of that. But we're never going to have good quality dialogue where everybody is contributing to that dialogue if they don't feel like that's a place that's safe for them to share ideas without somebody else attacking them for it. Where oh, Teresa, you're the other half of my brain. What am I trying to say here?
I think what you're trying to say is that people need to feel they can be honest, make mistakes, but also that they can call someone else out or disagree in a way that that is constructive. And it's a fine balance at different levels of teaching. That certainly looks a little different in middle school than it would in high school.
Yes.
But the balance is still, it's still a fine line, and it gets crossed sometimes, and you have to deal with it, and you just do what you can.
Yeah, and it's important to recognize that people feeling safe to express their thoughts is not the same as never being uncomfortable with other people's thoughts. Like, you can both be free to express yourself and not feel good about what somebody else is saying. You can feel uncomfortable with an idea and feel safe that you're not going to be attacked for disagreeing with it. And so, we're teaching science. And so ultimately, instead of just talking about opinions, and that's where things can really go sour, is that we're arguing based on evidence. What gives you reason to think that this is true? And as long as our students are arguing from evidence, then it feels less like personal attacks when we disagree with each other. And so we just need to work really, really hard at establishing those patterns of behavior for the whole classroom, and making sure that we are always consistent in holding our students accountable for those behaviors.
I think it's also fair to say that making room for all voices and making sure everyone has a chance to be heard doesn't mean requiring everyone to speak. It doesn't mean cold calling on students who might have a panic attack if you do that to them. It just means making sure that they have a way, whether it's in a whole group conversation or a small group conversation, or a one-on-one conversation, making sure that those students have the time and the space to ask the questions that they have and be a part of it. Some students are very fully engaged as listeners and don't speak much, and they might be comfortable with that, and that's okay as long as they're not being drowned out or spoken over, in my opinion.
Yeah, and some other things as far as classroom dialogue goes, when we're not in a board meeting, is that we want to make sure that we're asking questions that aren't direct questions that have like a yes or no answer, or that have one specific clear answer. We want our questions to extend the conversation, to make them think, and to question whether they really are right or not. Whether they are right or not, we want them to wonder whether they've got the whole picture. So we want to ask open-ended questions. And this, Teresa, is where if we had time, we would want to also show that learning pit video. So shared in, it's right there on Teresa's screen right now. The learning pit is a video that I would very strongly encourage everybody to watch. There's a YouTube link there and the guy's website. But
there are some cool posters on his website. So
yes,
once you watch the video, you might want to print some posters.
Yes. but the learning pit really gets into the kinds of questions that we want to be encouraging in our students, and the kinds of questions that we want to ask our students, which takes me to the last thing that I want to bring up about whole class dialogue, which is just that you have to have a poker face, and if you don't have it, you have to practice it every day. Where it comes back to Clever Hans, if you're nodding your head in agreement with everything that every student says, and there are times when I want to be encouraging to them, but if we're just always nodding in agreement, or if we're giving those subtle cues of, yes, you're on the right track of what I want you to talk about, or no, you're not, then we end up steering the conversation in ways that are not productive. They're not helpful. And so, like, I would ask the same questions of a group, whether I agree with them, or not a group, but a student, the same follow-up questions, whether I agree or disagree, because I don't want my responses to be what drives students to think, yes, I'm getting it right, no, I'm not. And Teresa, I've got 4:59. Did you want to put up that last slide?
Yes.
Just to make sure we get that information out there.
Yep.
And then we can field questions as much as you want.
Yes, it is. We want to make sure anyone who wants or needs to leave right at 5 is able to do so. And I can't, sorry. I've got my screen such that I can't get to my presentation. Let me, anyhow, once I figure out, sorry. How do we see it? I don't know. I can't see my,
I could.
All right, hold on. I'm going to stop sharing for a second. And I will say thank you to everyone who is here. And what I'm trying to do is put up our contact information, and
which you can see in the slide deck in the shared folder.
Yes. And I believe that both of us will be happy to stick around if you have further questions or other things you'd like to discuss. If you need to go, didn't want to go without saying thanks again for spending the last few hours with us. There we go.
Yeah. There it is.
There we go. All right.
Thank you guys so much.
Yep.
Thank you.
Thank you.
Thanks, guys. It was awesome.
Thank you.
Thank you.
Thank you.
Thanks for coming, everybody.
Yep.
And yeah, feel free to email us, shout at us on Twitter. My phone number's there, and Teresa's, I assume, because we're both happy to have you text us with questions or anything like that. So is there anything anybody wants to ask us?
People meet you this summer.
Say that again, Wendy. I didn't.
People see you.
Where can they
Where
see
can
us
people
this summer?
see you this summer? You can promote yourself.
Okay, you can come visit Teresa and Jeremy in Boston, the greater Boston area this summer, by attending a biology, middle school, chemistry 1, chemistry 2, or Castle physics workshop. You can also hang out in Cleveland and go to one of Jeremy's doing physics,
electricity and magnetism, and also middle school.
Middle school. So they're really great.
Some of us will be at the AMTA conference in Chicago.
And at ChemEd this summer in Naperville.
Yep.
And I read people were in my group, the Chicago people were thinking about it. So at least go to the AMTA conference, I mean.
They should go to the AMTA conference.
They should. It's a whole lot of fun. And I'm not just saying that it is. That it, yeah.
It's also really fun because I know so many of you from Twitter.
Mm-hmm.
Like Katie, I follow you on Twitter, and Joe, I follow you on Twitter, and Doug, you and I go way back to Intro to Modeling. Krista, you're not on Twitter, are you?
I am on Twitter, but mostly follow and don't post much.
Yeah.
Oh, I don't know if I follow you, or I don't know if you follow any of us.
I know I follow some of you all, but yeah.
I have a quick question.
Yeah.
Yeah.
Well, so my question is, and again, middle school, so you have to take that into account. But a lot of times when I ask my work groups to break up and whiteboard their answers to, particular question set, it's often where their default is, well, we don't understand or I don't understand, which means give me the answer. I don't want to have to think about this.
Mm-hmm.
And I'd like a more effective, again, I'm a first-year teacher, I would like a more effective response to that, because it's something that probably happens, almost every single time I whiteboard.
Yeah, that's a hard one, and it doesn't go away by 11th grade. They want to know that they're right. What's that, Teresa?
I said I wish it didn't.
Yeah.
Sorry.
Oh, please. But I think, to me, the key is to just hold firm on explaining to them that you're not trying to leave them hanging, you're not abandoning them, you're going to help them, but the way that you're helping them right now is to let them work through their own ideas. And I know my 11th graders in September are not excited about that answer, but I've just got to hold firm to it. And, what I am doing is the right move for you to figure things out. Sure, I could tell you the answers, but, how many times in our own lives have we been told something true and then not known it 5 minutes later? And that's something that, my 11th graders certainly recognize, that having been told something does not mean that they understand it now, or that they remember it even a few minutes later, because it's a whole lot easier to agree with somebody than to think your way through that. And so I'm just with kids about, why am I doing this? I know it's uncomfortable, but I have a good reason, and I'll explain myself because it's that important.
Okay.
Sometimes
and then
it helps
tolerate the eye rolling, right?
Yep. You have to
Well,
become.
they'll still eye roll.
Yeah. You have to become immune to eye rolls if you want to last more than 2 days, I think. But you can. Sometimes it helps to say, well, let's take a step back. What keep going back and back. Where are you stuck? Why don't you know? Tell me what you do know. What's the question about? And just keep trying to come up with different ways of asking the question until you get from one kid in that group some word that they can use as a springboard to put something on the board. And often it's just that part that they're not going through their own process internally to figure out where they need to start and what this might be related to. Sometimes they have, and they just don't want to admit it because of the particular dynamics of the group. And so if they need a grown-up standing there to walk them through that discussion piece, sometimes you can be that facilitator. It's hard, though. It's so much easier just to give them the question, to give them the answer. So much easier. Takes practice.
Cool.
I asked them if their brain is hurting. And if they say yes, I said, good. That means you're working.
Yep.
Right.
As you can tell, I'm not really nice to my students.
That's not true. If you don't know Marielle, that is not true. Anything else that anybody wanted to talk about? We were pretty rushed at the end there.
They're all looking for your sage advice and wisdom.
Oh, well.
Came to the wrong place.
Well, we planned for Teresa, I think our plan could have taken us through about 6 hours if we.
Easily.
Yeah. So I mean, settle in, everybody, because we're going till.
Yes.
I've got to get going here, but I just want to say thank you one more time. It's been awesome. I really appreciate all your help.
Yeah, thank you. And you all know how to
Thanks
find
for
us
coming,
on
Joe.
Twitter and email and everything else.
Yeah, thank you so much.
Yeah, thank you.
Thank you, Kristen.
All right. Awesome.
Thank you.
Yeah, thank you. And there's Tabitha.
She misses you guys. I
know.
mean, Jeremy, she's never actually met you, but you know.
I can't
Or-
wait. I can't wait.
And I'll provide you with it. I'll provide you with the Zyrtec or Claritin or whatever you need.
Yes, please and thanks. Yeah, so once I get to Boston, I'm just hanging out at your house like all the time. Did I hear Katie starting to talk, or?
Yeah, I was wondering if you knew of any funding sources to attend a workshop. Because in Michigan, we've always had a grant, which had been really nice, but it looks like that grant has ended to attend workshops in the state.
So,
What kind of workshop would you be looking to attend, Katie?
Biology.
Biology. Okay.
I know for Kim, but
yeah.
Yeah, I don't know.
Honestly, Katie, last
So
year
for-
oh, sorry, go ahead, Wendy. Wendy's just, you were cutting out a
No,
little
no,
bit. Sorry. Donors Choose, we had somebody get it funded in a week last year.
came from California.
Yeah, came from California out to Boston, and didn't have any support from his district for funding. He put up a Donors Choose. We posted it on Facebook and Twitter, and it was funded in like a week.
So for the Massachusetts one that I was looking at the dates, does that registration fee include housing or no?
It does not. We do have a bunch of people coming though, and so hotels are expensive in the area, but we're trying to kind of get people together who might be willing to do like a shared Airbnb.
When we have some really great people who are coming, we're happy to connect you with them and help you guys like kind of coordinate that as best as we can. And we think an Airbnb would likely be a better option than a hotel if we can help it, just because you can also have, you know, a kitchen, which might make things a little easier. And yeah.
Okay.
Yeah.
And if you can come, I'd really love to chat with you about, you know, the CTE stuff. I think it would be really cool to talk.
Yeah, we'll see what can happen. If nothing else, I'm planning on going to the AMTA retreat.
Awesome.
That's only like a 2-hour drive from where I am.
Yeah.
But Mike Gallagher is still supposed to be planning. So there is funding left over from last year. I know there will be some follow-up sessions.